All right, today we are getting right under the hood of the machine that, let's be honest, put the entire world in motion, the internal combustion engine. I mean, from your car to the planes in the sky, this thing changed, well, everything. So how does it actually work? Let's dive in.
You've probably done it 1,000 times, right? You hit the gas pedal, and your car just goes. But have you ever really stopped to think about what is happening in that metal block up front to make that happen? It's like this little bit of magic, and it's both way simpler and way cooler than you might think.
And here it is. The big secret? It's explosions. Seriously, thousands of tiny, perfectly controlled explosions happening every single minute you're driving. The real genius of the engine is how it harnesses the raw, violent power of all those little detonations and turns it into the smooth, consistent force that gets you down the road.
So, okay, how do we get from a bunch of explosions to actual, forward motion? Well, it all starts with a really basic idea. At its heart, the internal combustion engine is what scientists call a heat engine. So what does that actually mean? Well, think of it like a chain reaction. You start with the chemical energy that's locked inside gasoline. You burn it, which turns that chemical energy into a whole lot of heat, thermal energy. And then that heat is what does the actual work of pushing things around and making the engine's parts move. Now here's where things get really interesting. The engine in your car is an internal combustion engine, and that word internal is the key. It means the fuel burns inside the engine itself. That's the secret to its success. It's way more efficient and a heck of a lot smaller than an external combustion engine. Think of an old school steam train, where you have a giant firebox on the outside just to boil water on the inside.
Okay, so we've established that we have these explosions happening inside the engine. But what are they actually pushing on? It's time to meet the key players in this mechanical drama.
Think of it like a little play. The cylinder is the stage where everything happens. The piston is our star actor. It's the part that gets blasted up and down. The connecting rod is like the piston's arm, and the crankshaft is the big wheel that the arm turns. It's a really elegant, simple mechanical system when you get right down to it.
And this is the engine's big magic trick. It takes that straight up and down motion of the piston, that linear force, and it converts it into powerful, spinning, rotational motion at the crankshaft. And that rotation is what eventually makes it to your wheels and moves the car.
So how do all those parts move together in perfect time? Well, they follow this very precise four-step routine over and over and over again. It's called the four-stroke cycle, and there's a super easy way to remember it. Suck, squeeze, bang, blow. Let's walk through it. First up, suck. The piston moves down, and just like a syringe, it sucks in a fine mist of fuel and air. Next, squeeze. The piston shoots back up, compressing all of that fuel and air into a teeny tiny space, which builds up a ton of pressure. Then comes the main event, bang. A spark plug fires, igniting that compressed mixture, causing a massive explosion that slams the piston back down with incredible force. That's the power stroke. And finally, blow. The piston comes back up one more time and pushes all the used up burnt gases out of the cylinder. Then the whole thing starts all over again, thousands of times a minute.
And get this, here's a crazy little detail. For that entire four-step cycle to happen just once, the crankshaft has to spin around 2 full times. So for every single bang, every power stroke, the crankshaft has already completed 2 revolutions. Now that's the story for a gasoline engine. But you've probably heard of diesel engines, right? They get the same job done, but how they get to the bang part is totally different and kind of brilliant. You can really see the difference side by side here. A gasoline engine, remember, sucks in a mix of fuel and air, but a diesel engine, it just sucks in plain old air. The biggest difference, though, is how it ignites. Gasoline needs a spark plug. A diesel engine, well, it just uses raw brute force pressure.
And this is the really cool part. A diesel engine squeezes that air so hard, it compresses it so much that the air itself gets incredibly hot. We're talking hot enough that as soon as the fuel is sprayed into the cylinder, it just bursts into flame all by itself. No spark plug needed. It's pretty amazing.
So when you take a step back and think about this whole process, this ingenious cycle of combustion, it's really no surprise that it completely transformed, well, everything.
Just look at this. It's literally everywhere. The car you drive, the trucks and buses that move our goods and people, the ships crossing the ocean, even the tractors growing our food, and the generators that give us power. Pretty much every part of modern life was built on the back of this one invention.
And this quote just nails it. A prime mover. That's basically a fancy term for fundamental source of power for an entire civilization. And for the last century, you could argue that the internal combustion engine has been the most important prime mover we've ever had.
So there you have it. That simple, powerful four-step dance of suck, squeeze, bang, and blow is what literally moved the 20th century. It really makes you wonder, though, what's going to power the next one? What do you think the engine of our future is going to look like?